going to push our studs all the way through until they drop down to the bottom. And then we can run the rod all the way forward. Production assembly here. It's very useful to hold our crankshaft. And this bearing has quite a bit of wear from being used in the lab, used and abused in the lab here. Still plenty good for us in the lab, still a lot of life in there, but if you got this far in the field and you're removing these components, you should just replace that. Here, pull it out, get our crosshead section here. It's just normal wear on here. You see it's clean. Plungers look good. Our wrist pin is in place, still centered in there, locked in place still. You can see the bore for our shell bearing looks good. Everything's clean. Ready for a new one. We'll hold up the weight, because the plunger and the crosshead are quite heavy, so we'll hold those in place. We'll look at the bearing here. This is still in real good shape. We go to remove the bearing, you'll notice a tang on this one end. You'll slide it out this direction, not drop it. Take a look at the surface in here. Everything looks good. And look at our crosshead. Just normal wear right there on the edges. That's fine. Wrist pin's good in place. It's all normal wear right here. Plunger looks good. crosshead out of the bore, supported here. Pull it up, look at our bearing. Got some wear in here. This is all normal. There's quite a few hours on this from our running in our lab. We'll slide the shell bearing out this way. Notice the tang on the one end fits right in the tang slot there. Inspect the surface in here. Everything looks good. We'll look at our crosshead here. All real good wear on there. Look at our plunger. Everything looks good. Alright, we'll look at our bores in here. We're going to want to look for any score marks, gouges. This looks good here. We don't feel any grooves in there. Same here. Those all look good. Look down in the bottom of our sump here for any debris. This all looks good. After our inspection is done, we go to reassemble. I'm going to go ahead and use these same bearings again back into our, since this is just our lab pump. Again, if you were this far along into your pump and you had some wear in your shell bearings, it'd be a good opportunity to replace them, although these are just fine. This is all normal wear. We're going to want to install this back in here with our tang riding into our slot. Since these are used bearings, they'll have a little bit of a compression on them, so I'm just going to take and spread them out a little bit so they'll fit in here, a good tight fit. She'll hold them in place. And in the up position here, the number is always going to be up, and that is located here. And then also our matching caps will have a number on it, so you want to make sure those numbers match and they're in the upward position, because our lubricating hole for our wrist pin is located in the upper portion, which is on the area that has the upper part of the rod, which has a number on it. And you can't really see it, but there's a lubricating hole in there. So we'll support the front plunger and crosshead and slowly insert it into the bore and rotate it to help you to get it aligned. It should slide right in nice and easy. We'll push it all the way forward so we'll have enough clearance for the crankshaft. That one looks good. Move on to our next plunger here. We've already inspected. Looks good. Again, we'll spread out our shell bearing just a little bit to give it a little bit of a compression fit. Slide it into place. Again, numbers in the upward position. Locate it into our bore. Slide it right in and push it all the way forward so we have enough clearance for our crankshaft to get in here. Also, if you have a bearing that looks like this, these bearings can be used either direction. Since this has got more wear on it because it's on the thrust side or the loaded side as it's going forward, we could use the back bearing here. Again, numbers up. Upon assembly of, are you ready? Upon assembly of the crankshaft into place, we have this nice tool to help us hold it, but it would require two people to put this together. One thing we encourage is, as you put it in the bore here, for the person to be in the front there, got to bring it into place, set it down on the journals, and work its way in here to the next journal, till you get to the other side of the bore. You can rest the crankshaft on the bearing support here and on the journal to help you assist in loading it into here. Line up your hub on the other side. Continue to slide it in the bore. Now we're getting to the bearing surface over here. You're going to want to kind of just lift up on the end of the crank, slide it right into place. Snug a few of these down to hold them in place. Go back to our caps. When we inspected our bearings, they're okay to put back together. Line up our tab. Slide our bearing shell into place. Again with this one. And with our fine bearing here as well. Okay, now, alright, be able to push back on the plungers. We'll remove the diaphragm plate. Alright, push back on this. And maybe you want to get a shot back here, thus guiding. Guiding the push rod onto the journal. Okay, with our push rod forward, we need to install our studs here. And you'll notice they have a D-sharp shape pattern on the back so that it can go into a locking position. So I'll go ahead and fish this into the hole. Adjust this crank a little. Takes a little finesse. Okay. Alright, once our studs are in place, we want to make sure our shell bearing has not moved out of its position. We grab our end cap here, inspect it again, our bearing's in place. Carefully place it over the studs so as not to push them through at this, and line them up. Put a nut in place to hold the one stud that we know is already all the way forward in place as a placeholder. Pull the other one through. Okay. Now we're going to want to torque our studs to 100 foot-pounds or 135 Newton meters. And after we torque that down, we want to make sure we have free rotation of our crankshaft so we have no binding from our bearing. Bearing looks good. Position our crankshaft. Move forward our next plunger or reverse. Have to line up. Grab our next stud. In the lab, we've designed this tool, makes this job a lot easier, where we have put a magnet on top of the stick, holds the stud in place. We line up the flat portion here, rotate our crankshaft down, and pull the stud right through. Makes the job a lot easier. Inspect our bearing again. Everything looks good. Line our number up. Again, numbers up. still spins good. Port the carrier bearing housing bolts to 12 foot-pounds or 16 Newton meters. Protection cap covers, which is also the seal bearing seal cover. It's also 12 foot-pounds or 16 Newton meters. After installing the pushrod assemblies, we will line up the diaphragm plate. One thing to look out for here is that you'll have proper alignment of the cylinder to the plunger. It might line up pretty good now, but when they're new, they're going to be misaligned, and so that's something we have to be careful with. We go to assemble this, and we have a nice lining up of the plungers to the cylinders, and if they're not, you will more than likely get stuck here. That being the case, we can turn the crankshaft in and out, which will self-align the plungers inside of the cylinders. And once you can go pretty much once around, it should hold together just nicely. Our holding bolts for diaphragm plate. Okay, line our diaphragms into their beads. Okay, bring our manifold into place, line it up on our studs, forward, lock in place, take a nut, it's safety to hold it up to the diaphragm plate. Alright, we put our nuts on the front and check the side, and they should be flush up against here, showing that there's no diaphragm bead stuck in between the two components. We're going to bring the nuts and tighten them up temporarily until we put our final torque on. Wrench set to 450 foot-pounds or 610 Newton meters. So I'm going to do our final torque. Starting from the center, we'll do a crisscross pattern on our bolts, on our nuts. Grease up our seals for our inlet valve plugs. Alright, put in the inlet plugs. Torque them down to 300 foot-pounds or 406 Newton meters.